say that chemistry's my hustle. Your brain is like a muscle. So settle in because it's time to flex.
Good morning, everyone. So in this last demo video that you just looked at, you were looking at the reaction between sodium hydroxide and calcium nitrate. Calcium is one of these group 2 elements. So in this table, we see that there's a PPT when we put these two compounds together. That was the white solid that you saw formed in the video. That was the cloudy precipitate. Well, precipitate. There we go. So, I'm going to warn you that precipitate reactions are kind of confusing. So I'm going to try to help make this a little bit easier. We reacted calcium nitrate with sodium hydroxide. We formed a precipitate, and that's what this table is showing us. But let's break it down into the chemical reaction. Now, all of precipitate reactions are going to be the double replacement type reactions that you've seen before. We have sodium hydroxide, and you know how in the video it was a clear liquid at first? That was dissolved in water. Another way of saying that is aqueous or aqueous. And we also reacted that with something else that was aqueous, and that was calcium nitrate. Remember, I know that because it's a clear liquid, it was dissolved. And let's actually stop right there just to make sense of one thing. You should write this down because it's going to help you for later. If something is soluble, if it dissolves in water, that is something we call aqueous or aqueous. If it's insoluble, then we say that it forms a solid. Okay, so reacting these two together, one product is going to be sodium nitrate. Now, how would I know that? This is just a review of what we talked about with chemical reactions. This is a double replacement reaction, like XY and AB. Just like two dance partners on the dance floor, there's going to be some swapping of partners here. X is going to start dancing with B, A is going to start dancing with Y. So one of our products is going to be that sodium nitrate. I'm going to leave a little space for the state of it. And then calcium hydroxide will be the other product. Now, how can we determine the states of these two products? Using solubility rules is the answer. And that's what you're putting together here in the conclusion bit. You're putting together the solubility rules. Some of them are given to you. Like A here. In A it says group 1 elements, example on that would be like sodium. Sodium elements are soluble. Or C, nitrate, NO3 minus, are soluble. So we have a nitrate compound right here. And if it's soluble, what am I going to put down? Excuse me. What am I going to put down for the state? If it's soluble, I put aqueous. All right. How about the calcium hydroxide? Well, going back to the reaction, we know that a precipitate forms. So we kind of know that this is already a solid. It's not the sodium nitrate. So the solid that formed must have been the calcium hydroxide. If we had a solubility rule, we could have figured that out without actually doing the reaction. So does that mean that all calcium compounds or element 2 compounds are form precipitates? Not so fast with that assumption, because over here where it says, this is another example, we've got calcium nitrate with sodium chloride. it doesn't form a precipitate. Let's write that reaction down now. So we have sodium chloride, which is aqueous, reacting with our calcium nitrate. Forming sodium nitrate again. And calcium, do your double replacement, calcium chloride. How do I know it's CaCl2? Remember that we have to always re-swap and drop. 2 plus charge on calcium, 1 minus charge on chloride, so I know it's 2 chlorides. What is going to be the state for calcium chloride? We know that sodium nitrate is aqueous already. Well, in this reaction, using the table, we can see that there's no precipitate. Because it says that. So no solids will form, therefore this one must be aqueous. So what can we say about calcium or element 2 compounds? Well, in this case, it was insoluble. The case up above, this one was insoluble. And in this case down here, it was soluble. So we can't make a claim one way or another. And in other words, for B here, compound 2 elements are sometimes soluble. Okay, let's do one more together, and then I'm going to leave the rest up to you. In D, for ammonium compounds, ammonium is NH4 with a plus charge. The only way we can make a claim about what happens is by looking at our table. And the only place that ammonium shows up is right here. Notice that regardless of what it reacts with, no precipitate is formed. We can make the claim right away that ammonium compounds are soluble. And I could verify that with you by writing down the reaction. Let's just focus on one of them, like this one here. So we have ammonium nitrate with sodium chloride reacting, double replacement reaction to form sodium nitrate, which, as we know from before, it's a very popular compound. It's aqueous, and that forms ammonium chloride, which also must be aqueous. How do I know? Because no precipitate is formed. That's what it says here. So that's how we can make the claim that it is soluble. So these can be tough. Sometimes it helps to write out the reaction, and you can make some assumptions about these different compounds just by looking at this table. Some of them are pretty clear, some of them not so much, but use the rules that we've already talked about. If you come across a nitrate or a group 1 element, we know it's soluble. If you come across a group 2 element, that doesn't give you much because you know it's sometimes soluble. Hope you're doing well. If you have questions, make sure to email me or show up to my office hours. Have a great day.